Hello and welcome to Chapter 11. So in this chapter, what we're going to be doing is primarily looking at the RPC side of the MMO. So, what does RPC stand for? RPC stands for Remote Procedure Call, and it's basically a blanket term that's used to describe a method of communication between a server and a client. So what I really wanted to do is I wanted to make the actual underlying communications of most of our systems. So let's say, for example, the login system or the character creation system or the movement system. And I wanted to abstract it in such a way that would very easily allow the creation of more types of messages that can be sent from the server to the client without necessarily requiring a substantial amount of code to do that. So there's a lot of heavy lifting that this framework is going to do for us behind the scenes, and it really is going to be the backbone of pretty much all the communication that will happen between servers and clients. Now, because this system is so built in and embedded into the whole MMO, and because communication between the server and the client is such an important aspect to optimize for a multiplayer project, particularly an MMO, there's going to be a lot of work that we're going to have to do in order to make such an abstraction actually viable from both a bandwidth and a performance sense. But there's a lot of interesting tricks that we can employ that have to do with things like caching and doing dynamic code compilation, and even a custom serialization method that we will be talking about in this chapter that we can do to make this an actual viable system. So in this video, I kind of wanted to talk about the different moving parts that we're going to put together. So this framework is very underlying. It's very abstract, and it's going to pretty much be the platform in which we build all of the other features on. It's also important to note that we are not going to be using the region server just quite yet. I wanted to get the RPC framework up and running so that we can start doing some really cool things with it, and then we'll look at how to load balance it later. And that means that some of these components that we're going to be writing in this chapter will have to be modified to take advantage of horizontal scaling, so that, for example, a region server can be put into your server cluster, and it could dynamically offload some of the work that another server would have to do. And then just some ideas that I have floating around my head. For example, I wanted to be able to dynamically adjust which servers get which parts of the zone, and so on, because we're really shooting for a seamless world here that isn't zoned technically. And so like I said, yeah, we will have to rework a couple of these components later down the road when we build that in. But I wanted to address that first for people who are aware that I am shooting for a horizontally scaled, seamless world. And so if you guys don't see any of the any communication between two different servers in this chapter, don't be alarmed. Fortunately, I already have in my mind a way that we can easily migrate this RPC system that works from just a single client to a server, or multiple clients to a single server, to a system that goes from multiple clients to multiple servers. And that would just require some little background communication between the different servers, but overall, the actual systems that we're going to be implementing using this RPC framework should be unaffected, relatively speaking, once we make that move. But there is a whole lot of work that we need to do even to get this RPC framework going, and once we have it going, we should start to be able to knock out some really interesting features. Like, for example, I really want to get kind of like a mini game type thing up and running by the time this chapter ends, just to demonstrate what we can do with the RPC framework. Okay, so like I said in this video, I just want to overview all the concepts, all the big players. There is a lot of code, and unfortunately, there will have to be a lot of classes written before we'll see something in Unity that we can actually play or watch communicate with the server. Now, to partly offset that, we will be developing most of these components with tests. So I'll have a test project set up in our solution, and then we will be running unit tests against the components as we write them, so that we can be confidently sure that they're going to work once we have everything in place. but it will take a little bit of time to actually get everything in place because, as you're about to see, there are a lot of moving parts. So I want to take this video as an opportunity to sort of establish the terminology that I've been using throughout the development of this system, because this terminology is incredibly important to be able to understand what's going on. So after you guys see a little bird's eye view of all this stuff that we are going to be doing, I want to go into some code examples, and I'm finger coding right here because we will be looking at code examples, but what I'm going to do is show you guys what the code would look like if this system existed, so that we kind of have a sort of a goal to get to. By the way, that's another interesting thing that I don't see a lot of people talk about in terms of software design, and that is whenever you have a really complex system like this, and once you know a language very well, being able to just open up a blank code file and just start hammering away against non-existent classes and interfaces and stuff like that to see exactly what you want the result of this framework to look like, even without the framework existing, is a very important tool. And that's actually how I developed this system. I was like, this is what I want it to look like. Now, how do I actually make that happen? How do I write the infrastructure in such a way that it would A, work, and B, not bog down the server? So we're going to look at some of those examples. I'm just going to type up a few examples of what I would like the structure of a login system to look like, without any actual login code, but how would the methods be written in such a way that they could be invoked on either the server or the client. And then I also want to show you guys how we would put together a basic actor behavior. And we'll define what an actor behavior is shortly. And then if we have time, we can talk a little bit more about the other high-level components of the system. And that'll give us a nice little roadmap of what we're going to have to knock out piece by piece until we can put this whole system together and actually have a playable game or a playable something. Anyway, okay, so this is an RPC framework, meaning we basically have two major entities that we need to be cognizant of, the server and the client. So we have our server, or let's put the client over here. We have a client, obviously, so that's the game, or maybe it's a headless client, for example. Like maybe it's a some sort of load test, load stress testing system or something like that. And then we have the server. Now again, at the moment, we're just talking about having one server. When we extend the system to have a multiple servers that are load balanced by region on the seamless zone, we will have to talk about server-to-server communication. However, what you'll find, though, is that this framework is robust enough to handle both client-to-server and server-to-server communication with little to no modification. There's a couple open-ended questions that I have right now of how I want to exactly handle that and how much difference there will be between the two. But primarily they should be pretty similar, and I'm expecting to use this exact same RPC framework for server-to-server communication as well as server-to-client communication. Anyway, so those are our two big entities. So now let's go ahead and define a couple terms. There are primarily going to be two different ways in which a client and server can communicate between each other. We will have systems, and we will have actors. So a system is a component that exists on both the client and the server, and it's going to be instantiated on a per connection basis. So an example of a system would be the login system or the character select screen or something like that, something along those lines. It's a unit of self-contained functionality, but it would necessitate the existence of an object on both the client and the server. Now, so in the case of our login system, for example, we would need pretty much three things. So we have client and server, our two big entities. I want to go ahead and introduce one more conceptual entity that I can kind of group things together with to show you guys what's going on, and that's going to be base. So as you see here, now we have our base and our client and the server. Base is up here to indicate that both the client and the server share a reference to this project. So now you're sort of seeing how this diagram sort of relates to the solution structure that we put together already in our project. So for a system to work, we primarily need three things. We need two interfaces on base. So for example, let's do the login example. So let's say I login system client, and then the I login system server. So the iLogin system client and the iLogin system server are two interfaces, and what they do is they describe the methods that can be remotely invoked by either the client or the server. So on the client, we're going to have something like the login system client. The login system client is going to implement. It's going to inherit for something else, but that's an infrastructure concern, not a concern of the concepts here. It'll implement the, not surprisingly, iLogin system client. And now we have our last thing. So these are two things. We have the two interfaces in our base project that are shared by both the client and the server. That's important because both these projects need a reference to those interfaces on a per system basis. Now we have the server. The server is going to look pretty much exactly like the client, except the words are going to be a little different. Because in the server, we're going to have our login. Well, that's a G. I don't know where that came from. Login system server. And obviously, it's going to implement the iLogin system server. And so what we have here is a case of bidirectional communication. And that is, the client is actually going to receive an object that is of type iLogin system server. But you might be going, hey, wait, I thought the object or the class that implemented that interface is all the way here on the server. How can the client have a instantiation of this object locally in its process? And the answer is, well, it couldn't, but what you can do is what basically our RPC system boils down to. And that is, we are going to instantiate a dynamic proxy of type iLogin system server. And so it'll have the exact same list of methods as the login system server component right here on the server. But instead of actually doing anything, when you invoke those methods, it will then shoot off a network request behind the scenes all the way to the server, then have the server actually perform that method directly on the object that it instantiated to fulfill that particular system. And so that means that we basically, in order to add a new operation, if you're familiar with Photon, you understand operations. They're the things like move or pick up something or whatever. So now, in order to implement a new operation, you simply need to add a new method to one of these base interfaces, for example, on the server, implement it on the server, and it just magically works. No additional work, no creating an enum, no creating any custom serialization, although there are serialization concerns that I will talk about shortly. Okay, so we have the login system client, the login system server, and we have our base interfaces. That is all you need for a system. Now, the way that I have this set up, or the way that I'm thinking about having this set up, is that we will annotate these types with particular attributes, and which will result in them being loaded up in the appropriate way. Now, to create a system, the only place that can create a system is the server. So the server might say, client 1, you are now logged in, so I'm going to remove the login system from you, and I'm going to add a player movement system to you, so that you can now move around in the zone you just got put in. Or I'm also going to add an ability effects system, or something like that, so that you can now have abilities, or be notified when you have an ability activated. So basically, that's it, really. I mean, the communication between the server to the client, remember I said this is bidirectional communication. The communication from the server to the client is done through the iLogin system client interface, which contains all the methods that the server can invoke on the client. So by invoking the method on the proxy, that request to invoke that method will be shot over to the client and be processed in Unity. And there's a couple other interesting things about this. The way I want to put this together is I do want my Unity systems to be game objects, or, well, in particular, mono behaviors, so that they can do things like show user interfaces, or you can configure them in the inspector in the form of prefabs, or what have you. I mean, there's a variety of ways that we could take advantage of that, and significantly reduce the amount of code you would typically need to write when working with any sort of networked operation. Okay, so that's basically how we are going to do systems. And again, if this is at all confusing, we will talk about the code for this. Actually, let's go ahead and just do the code now. Just the code for the systems. I just want to show you guys how this diagram sort of relates in terms of actual code. Although the code won't compile, I do want to go ahead and put some together. So what I'm going to do is I'm going to go ahead and I'm going to open up a new instance of Visual Studio. And I'm just going to create a new console app. And then I'm just going to start throwing code inside of it to give you guys a feel of what the process would be like for actually implementing a login system. How many steps do you have to go through to implement a login system with this RPC framework that we're going to put together? And again, understanding this, again, you are probably confused right now, which is fine. But at least understanding the high-level aspects of the system is going to be very important once we get to implementation. Because implementation, unfortunately, is not going to be very trivial. We're going to have a lot of moving parts, and I wanted to give people a very nice little overview of those moving parts before we moved forward. So let's go ahead and I have a console app. You guys are now on console app 228 in my garbage folder. I have a folder on my hard drive where I stick all, like if I say, oh, I want to write something in C# real fast, I'll just create a new console app in this folder. So I'm up to 228. It's actually not a lot, honestly. Anyway, so I don't know how I did that. I don't want to start the narrator. What did I press? Go away. Okay. Let's hope it doesn't narrate things. All right, so login system. So login system. Okay. Hold on. I'm gonna pause the video and figure out how to stop this. All right, that was scary. My computer just started talking to me. Anyway, all right. So login system. So a login system is basically the code that we would write to allow the user to take that token that we've generated when we have the launcher and pass it into Photon so that Photon can establish what user the client should be logged in as, or particularly what roles that he might have, is he allowed in the game, and so on. And then I'm also going to throw in a few other random things just for illustrative purposes. But anyway, so let's talk about the three major parts. So we have our base, and we have our client, and we have our server. So imagine these comments right here that I'm just dumping out here right into the text file itself. Imagine these comments delineating different projects. So imagine any code I put into this would be code that we would put into our base project, or any code I would put into this goes in the client or the client Unity project, and obviously any code that goes into this will be the server project. Again, this isn't going to be compilable real code. This is just illustrative of how the RPC framework will look once it's all implemented. Okay, so like I said, in the base project, we need two interfaces for any system. So for example, we're going to need the iLogin system server interface, and then the iLogin system client interface. And again, this is getting into an implementation detail that'll become apparent later. This isn't actually necessary for the conceptual overview, but I'll show it anyway. These two interfaces I want to be dynamically found by the entire RPC framework and be automatically loaded in as appropriate interfaces that can be used for the RPC. So we need to annotate them with attributes so that we can scan our app domain, find all the types that have these attributes, and process them differently. So I'm just going to say something like system interface, or maybe I'll use component interface so we can reuse this between actors, and this component's a very generic term. I haven't decided the name of the attribute yet, but just use component interface on both these. Okay, so what would these look like? Well, the iLogin system server would have a couple methods on it. The most basic method, or the most obvious method, is going to be something like iRPC response login, or how about token login, string token. Alright, a few interesting things to note about this is if we want any feedback from the server, we will need to use a special type called iRPC RCP response. RPC response. And what that does is it signifies to the framework that this is a method that can return something. It could fail, return a debug message, and so on and so on. So if we didn't want to return a response with our RPCs, we could say something like void do something in tag, for example. And this will return no acknowledgement from the server when it's completed, and there'll be no way to know if it succeeded or failed. This is important from a performance perspective on things like movement, or primarily movement. Most things, or not most things, but some things you really do want some feedback from the server indicating whether your process succeeded or failed. For example, if we try to log in with an invalid token, we would want to receive that message. Or if we tried to use an ability but we didn't have enough mana for it, we would also want to receive an error message. In addition, there's going to be one more way of writing a method like this that for server-side interfaces, and that's going to be the iRPC response of, let's say, string. So these methods are actually going to return not only an indication of success or failure, but they're also going to return actual data all the way back to the client. So it'll be very useful for operations that result in some data being created and the client needing to be made aware of it. So anyway, these are the three forms of methods that you'll be able to add to a system server interface. So let's look at our client. What would our login system client need? Well, in all honesty, it probably doesn't need anything. But for illustrative purposes, I can go ahead and add an arbitrary method. I can say, I don't know, blow up player's computer. Something like that. Something that the server is going to need to tell the client to do at some point. Okay, so this is the first aspect of how to make a system. We have our two interfaces. We have what the server can do on the client. These are just expressed in terms of very simple, straightforward methods that everybody is familiar with. They're just C# methods and nothing fancy about them. And then we have what the server can do to the client. Same deal, straight up methods, straight up interface, nothing special besides the attribute itself. So now let's look at the client. So what would the client look like? Well, look something like the login system client. Now, the login system client, my systems, while I've been developing this RPC framework, I've noticed the need for some base classes, just in order to get some basic functionality that all systems will share out of the way, and also to address some of the interesting differences between creating an implementation of a system for a Unity client or creating an implementation for a system for a non-Unity client, such as a WPF application or console application. So, in this case, I'm pretending that we're in Unity right now. We're in the Unity client. So you would inherit from something like Unity System. I haven't decided the name on that either, but let's go with Unity System for now. So Unity System. Now, this will have to be a generic type, and we'll see why very shortly. And basically, we're just going to state to the system that we're implementing which system we're implementing. And we do that by specifying iLogin system client, or let's start with server. I always like doing server first so it's consistent. And then iLogin system client. Now there's one more thing that every system needs to do after it's taken care of. This is infrastructure stuff right here. What I have highlighted is just basic framework stuff that you will have to do in order to get this to actually work. So once you get this out of the way, you can just ignore it. The last frameworky type thing we need to do is actually implement iLogin System Client. Now implementing iLogin System Client is going to necessitate that on our client we have a method called blow up player's computer of type void. Now, obviously, because otherwise if the server told us to blow up player's computer, what would we do? We need to actually fill this out with some code on the client. So I could say public void blow up player's computer, so that and you can notice I'm now implementing this method. As you can see on the gutter over here, it says implements method. And then I could do something like, I don't know, application.load level stuff and throw new invalid on it. It doesn't matter. Actually, I'm not going to keep that because it's going to keep on popping up with that annoying thing. Anyway, the point is that I could write whatever logic I wanted to. I could, say game object.transform dot position equals new vector 3, 100, 100, 100. The point I'm trying to illustrate here is that we're pretending right now we're inside a Unity. So this class will actually be instantiated on our client side, on every single client that has the system. And it will be able to perform whatever logic it needs to. It'll have access to the entire context of the client so that it can do anything it needs to do. Okay, so the next thing I want to show before we move off the client is what would invoking something on the server be? Like, for example, let's say I had a public void on GUI right here. Remember, because these are mono behaviors. And if I had if GUI dot button, and I know I'm not passing in a rect for position right now, but whatever. So if I say, or let's say if GUI.button.login, so if the user clicks on the login button, we need to tell the server to do something. In addition, we also need to disable the GUI while that process is happening. Then, if there's an error, we need to show that error to the user. So how do we do all of that stuff? What would normally be a very complicated sort of thing to do in a more traditional framework. How do we do that with this framework? Well, by inheriting from Unity system right here, we are going to gain access to an object, or to a field called server. And the server object is going to be of type iLogin system server. The reason it can be that type in a strongly typed fashion is because we're passing in iLogin system server as a generic type argument to the Unity system class. So it's going to very helpfully put in a little field that will allow us to access the server. And it'll be of type iLogin system server. So what I can do is I can say, if GUI.button login, I can say server dot token login ASDF1234. Okay, so that's all great. Once this code executes, it's going to serialize that method invocation. It's going to shoot it off over the server. The server is going to process it. But then what? How do we do something once we get a result back? And that's where things get really cool. I mean, if they weren't cool already, things are going to get much cooler now. It's a terrible sentence, but I hope you understand what I meant. So, what I'm going to do is I'm going to actually chain some method invocations, and I'll tell you how I can do this here shortly. So I'm going to say always enabled equals true. So first of all, I'm going to do this underscore enabled thing. When we hit the login button, enabled gets set to false, so that the button disappears, so they can't sit there and hammer the login button and make a bunch of login requests. So I'll say always enabled equals true, and then I'll say fail response error equals response.operation error. Okay, so what is going on here? Well, what we have here is an example of the API that I'm going to create for the iRPC response interface. So the iRPC response interface is going to allow me to chain these callbacks inline using lambdas so that I don't have to write any additional code anywhere else to get these little bits of logic to execute depending on what happened with the request. For example, at any time, whether it succeeded or failed, that the server finished the login request, it'll reset enabled back to true, which is important so the login form now displays again to the user. If there was a failure, however, we're going to extract the error and presumably display it to the user. I mean, I don't have a error field on this class because this class is just throwaway stuff I'm using to illustrate points with. But you can pretend that by setting operation error to error, or error to operation error, that we are now going to display the error to the user. So for example, invalid username or password, or your account doesn't have permissions, or whatever, blah, blah, blah. So the point is that we can inline our reactions to the server right next to the method invocation. And that's exactly why I opted for doing this RPC response thing. See, I can't have return types on these interfaces because this is asynchronous. Because when I do server.token, really? When I do server.login token, it'll return immediately. Execution will return immediately back into the main thread, and it'll do all its other gamey stuff, while the server is processing that request on its side, and the server could take some time to do that request. So the return types aren't going to be available immediately. That's why the only way in this particular style of RPC frameworks that you can facilitate the existence of a result is the only way is going to be to do something like this, where we have a special interface like IRPC response that is understood by the framework. And furthermore, allows us to describe what we want to have happen when the server is done. That's important. So this stuff will happen when the server is done, not when this method is invoked, but when the server has finally finished the login request. Anyway, so as you can see, I can add as many of these methods to this interface as I want, and then I can simply invoke them by doing server dot on the appropriate system. And that's it. So that is what the client looks like. Now the server is pretty much going to look the exact same, actually, just in reverse. So basically we have class login system server. So remember, I'm in the server I'm pretending that I'm now writing code that's going to be running on the server, not the client. So we'll have class login system server. It's going to inherit from something, probably server system, I'm thinking. iLogin system server and iLogin system client. And then it's also going to implement iLogin system server. Now to implement iLogin system server, of course we're not seeing an error yet because ReSharper stopped parsing this line due to system server not existing. But we would see an error because we haven't actually implemented these three methods. So the actual implementation of our server logic goes in the form of these systems. And we simply have to implement these methods. That's it. So I'll say public IRPC response token login string token, public void do something int a, and IRPC response string return something full stuff. Okay, so that's basically the login system server. There's really nothing that interesting about this aspect to it. There's a couple other things to note. For example, if I wanted to invoke something on the client, I would simply say client dot blow up player's computer. By simply doing client dot blow up player's computer, this method will be invoked, but on the client, which is, well, what an RPC framework does. The important thing to understand here is how little work you have to do in order to create a whole new system. No adding another entry to an enum or anything like that. Everything will just be handled transparently in the form of a very strongly typed and object-oriented manner. So anyway, so we can, in our server, we can communicate back to the client. Now, some people might be wondering if I'm going to do something like an IRPC response for client components. Like, is there any way for a server to know when a client is done processing something? The answer to that question is probably not. I'm probably not going to allow the ability for a client-side component to have a IRPC response, because I've never really found a need for it at all, and I think it would just add more complexity to the code base. So all client-side methods will be returning void. Okay, really the only other interesting thing to show here is going to be how do we work with this RPC response. Like, how would I return a failure versus a success, or how would I return data back to the client? Well, this can be made very easy with a helper class that we're going to write. And it's simply going to be something like, let's say, if token equals ASDF12345, I'll say return RPC response dot fail. And I'll say invalid token. Alternatively, I'll return RPC response dot valid or succeed. I haven't decided the terminology for those. But anyway, the point is that we simply wrap our operation errors and potentially our debug messages in a method invocation to our RPC response dot, and that'll be handled by the framework. The framework will notice we're returning an RPC response, it'll serialize it, shoot it back to the client. When the client receives it, it'll invoke these lambdas. Okay, what about returning data? Well, it's pretty much the exact same concept. Return RPC response, then I'll do something like with data, this is a response string. And we can get away with this because I will be using type inference on the with the data method, meaning that with data will be a generic method and it'll return the proper type that has the proper generic type argument supplied to it. Anyway, that's about it. I mean, as far as how the systems will work, that's all the framework. Most of the framework is going to be facilitating this style of communication, this style of writing code, and this style of networking. So I mentioned before that I have optimized this quite a bit. It could be even optimized further, but I believe it's at a respectable state right as it stands, and as a result, we're going to move forward with it. And then once we get some more counters in place so we can actually measure bandwidth in, bandwidth out, and CPU usage, we can look at maybe doing some other crazy stuff. But for now, we're implementing basic code compilation, reflection, all caching, and all that fun stuff, and we can get some pretty good performance with this. And all without massive switch statements or enums, which if any of you guys have done networking programming before, are very familiar with. Okay, so that's the system. Now let's talk about actors. Actors are going to be a little bit simpler. Actors and zones and regions and all that fun stuff. Pretty straightforward stuff. I'm going to go ahead and just create a new layer. Okay, so actors. An actor lives on the server. Most actors do anyway. So actors are mostly going to be objects on the server. Think of them like what a game object would be in Unity. They're typically going to be something visible, like, for example, a player's avatar or a mob. And they're also going to have behaviors attached to them. So we'll have behaviors attached to the actor. Behaviors are like Unity components. An actor is like Unity's game object. So we can have multiple behaviors attached to a single actor. Behaviors will receive, update signals from the simulation thread and all that fun stuff, and they are more or less just mono behaviors, just, not mono behaviors. But so far I've been talked about how they get seen by the client. Now, there's three facets to this. First of all, we have which zone are we in. So we're going to have things like instances, which are just where people go. So we'll have, a handful of people that can't see each other. So those would be our instances. And these would be things like particular dungeons or maybe mini games and all that fun stuff. Then we are going to have bigger worlds, and these I'll just call worlds. And right now we only really have one world planned, even though architecturally it wouldn't make a difference to add an additional one. So a world is where all of our players and all of our actors and the entire game that are not in instances, that's where they live. Right? So this is the first aspect. We have our instances and our worlds. And our worlds have people in them, and people can see each other. Instances maybe has 2 to, or maybe even 1 to maybe 10 people in each instance, and so on and so on. We are also going to further subdivide things by regions. So the world is going to be split into these regions. And the idea is that only players within a particular region can see players in that same region. When you get to a border of a region, things get a little bit more complex, but we can handle that as well. Also, this is when I talked about our region server, for example. This is where that comes into effect, because basically, so I'm taking a little detour right now of what I was talking about, but this is important to understand how we're going to be doing load balancing. What I'm going to do is I'm going to have multiple region servers, and a region server can own these multiple ones of these little squares. So let's say we have one region server that's simulating that, and then we have another region server that's, let's say he's just simulating these two regions because they're so populated. And then we might have another region server that is simulating the rest of it. And so the idea is when you get close to one of these server edges, you will have to connect to both regions' simulation nodes so that you can receive information from both of them in order to see what's on the other side of that seamless world. And again, the transition between different region servers will be seamless. But that's later down the road. But I just wanted to point that out since I had that diagram there. Anyway, so we have our instances and our worlds. Those are places where players can be in and see each other. And then inside of these worlds, we have our second level, which is going to be our actors. And our actors second level, which is going to be the regions, which you can see the regions right there. And then finally, we have our actors. Our actors are going to be located within regions, and they get subscribed to or unsubscribed from based on a bunch of different parameters and so on. So the question is now, how do we write an RPC framework that facilitates the ability for the server to simulate little objects, little game objects running around like mobs and doors and cauldrons and stuff like that, and be able to very easily send information to clients who may be entering and exiting particular regions very frequently. And so that's where behaviors and RPCs come in. So behavior is what controls an actor, like a mono behavior. So it's what controls an actor and makes an actor do what it does. Then we have RPCs. Now RPCs are owned by behaviors. So a behavior will typically have one RPC associated with it. Now this is a terrible term because it conflicts with what this framework is, the RPC framework. So I'm probably going to come up with something else to describe what these are. So this terrible term, just let's roll with it for the rest of this video, and I'll maybe come up with something better here shortly. But basically what it is a behavior can invoke a method on an RPC, and that method will then be invoked on the client's view of the actor. Because you see we have an actor and behaviors right here. On the client, we're going to have actors that are just views into what the actor, the server, is doing, and the actors will have RPCs on them. Right? So we have actors, which actors are going to be game objects, and they're going to be running around, and they have these little RPC interfaces on them, which are mono behaviors that are going to be attached to the actors. When a server behavior invokes a method on one of his RPCs, that's going to invoke the method on the corresponding RPC on the client. And so what this allows us to do is it allows us to create these components, such as presentation or color changer or movement or combat or ability effects and so on, and have the actual logic. So this is the logic of a particular actor behavior, such as an effect manager or something like that. And it allows us to send information to clients in a strongly typed way. So the clients themselves are not going to have any game logic, quote unquote, on them per se. They're not going to actually control anything, but they will receive messages from the component that does control them. And the RPC framework that we're going to write will handle all of this marshalling for us. It'll allow us to very easily instantiate these little RPCs and very easily create these behaviors, and have the behaviors tell the RPCs to tell the clients to do something. Now the great thing about this is these RPCs, whenever an actor invokes a method, or whenever an actor's behavior invokes a method on one of the RPCs, the corresponding version of that RPC on every single client that is within range to that actor will also be invoked automatically. One line of code. There will also be ways, I've come up with ways that allow me to only send particular messages to particular clients, also as both a list and as a single client. So we have the ability to facilitate some rather complex communication between our game objects on the server and the client, and it'll be actually easier than it was to implement a system. Because you'll notice, you might be thinking right now, what are these RPC things? Well, they're interfaces, and they're interfaces that we write in our base project. So for example, I might say something like, ability effect component. So this will be an interface that the behavior requests from the framework, and then the clients implement that interface, and then the server then controls that interface on the client. Anyway, so that's a basic overview of the way actors are going to work. So let's go ahead and take a look at a quick code sample of how we would write an actor behavior and how it would look on both the client and on the server. So let's jump back into our console application, and I'm gonna create a new file so we don't get anything mixed up with our other example there. And I'm going to go ahead and just do the same thing that I did over here. I'm going to bring over this comment, just get 3 of those in there. So we have our base, then we'll have our client, and then we'll have our server. So our base, let's say we want a component that allows an actor to change colors. So we'll have something like interface color change component, and it'll have a void change color float color. So I'm using a float array here instead of a color class, and we'll talk about that later in the upcoming videos. The point is that this will be a 3-item float array that contains values between 0 and 1 for R, G, and B. So how would our client look? Well, we would have something like, our client would actually have 2 classes. I'll talk about this shortly, or actually I'll talk about this right now. Client will have 2 classes. The first class is going to be the color change component, and it's just going to be a straight up mono behavior. And I'll have a public void change color color, and then we'll say something like render dot material dot color equals color, whatever. Then we're also going to have a color change. I haven't figured out what to call this thing either. Color change behavior or something like that. And this will implement a Unity behavior color change component, and I'll have a public void change color float color, and this will say something like game object dot get component color change component change color dot to color. So what's going on here? Well, I have two classes. I'm debating whether or not to have these type of classes actually be mono behaviors physically attached to the actor game object, or doing something like this, or doing a combination. Here's the reason. When we have these types of classes that are coupled heavily to the RPC framework, as in they both implement or inherit from a very particular class, and they implement a very particular interface that has particular constraints on it, I don't want to have a lot of logic in these. And the reason is because it becomes very inflexible and difficult to test. Let's say that changing the color of something required 250,000 lines of code. Would I really want to lock all of that functionality in one very specific use case of the server telling the client what to do? Or would I want to turn it into a reusable component that can be used to change the color of anything, anywhere, but just so happens that it's also used by this sort of component that's plugged into the RPC framework. So it's a very difficult decision to make. You're trading convenience with well, better code, I guess you could say. And I don't know if I want to do a sort of hybrid approach where very trivial methods like this would just simply be rolled into these classes, or if I want to do an approach that would necessitate the creation of other mono behaviors. So basically every actor behavior, RPC, would require two classes, one that receives the RPC requests and one that actually performs the logic, so that the logic is in its own little area. I haven't decided where to go with that, but I'll probably end up with a hybrid approach. And it becomes really important for things like ability effects, because that's a really complicated system to display particle effects and manage all the different abilities that can happen. And I want to be able to reuse that code both for the avatars of other players moving around, as well as the player himself, which you'll see when we get to movement, that sharing code between those two types of things becomes more difficult, because obviously the avatars of other players are controlled exclusively by the network, whereas the avatar of the player himself is controlled by a third-person character controller. Anyway, the point is that that's all you need to do on the client side to get basic actor behavior working. On the server side, it's also pretty straightforward. We'll have something like color change behavior, and it'll inherit from, I guess, actor behavior, and it doesn't implement any interface. It doesn't need to. And then what we would do is, in its constructor, I would say something like underscore RPC equals actor, create RPC, color change component, and then I'll say public void update. Let's assume that this behavior is updatable on the server from the simulation thread. I would say something like rpc.change color new float, or I don't even have to do that, I can just do that. 0.5f, 0.5f, 0.5f. So every server tick, it sends a message to every single subscribed user to change the color on their objects. So the cool thing about this is when this happens, the concept of an color change component gets sent to these clients. So the clients know that this actor is capable of invoking methods on the eye color change component. And then when we invoke it on the server, this method will get invoked, and then this method turns around and tells its attached game object to perform some sort of behavior. So really, all the systems would look like this, and we would be able to very easily, in a strongly typed fashion and very efficiently, implement, whatever systems that we would need to. This particular framework will handle quite a few different complex scenarios. Anyway, so that's how we would handle actors. And that's how actors would tell clients what they are up to and how to render them. You can kind of think of these little RPC interfaces as a view into the server that is then sent to each one of the clients. The clients can execute their own Unity logic in order to perform some particular action. Anyway, I think that just about wraps up what I wanted to go over in this video. We have a handful of other components that we're going to be implementing one by one. We have our component map, which is vital for performance reasons. We also have a method invoker, which will dynamically compile code to speed up method invocations of client and server systems. We have the concept of actor IDs, and we'll talk about that in the next video. Behaviors, we need to build a serializer, a basic binary serializer. Don't worry, it's not that scary. For the client, we have the client system manager, the system factory, the client transport, the actor factory, the client actor, and the client world. For Unity, or Unity client rather, we have the Unity actor factory, the Unity player, the Unity zone manager, and the Unity game world. For the server, we're going to have our region, our zone, our peer, our game server, and our client context. And those are sort of the high-level players of this entire framework. And once we get pretty much through all of those, we'll have both a system-based communication bidirectional framework as well as a actor-based one. So yeah, I think that just about wraps up what I wanted to go through in this particular video, and we'll see you guys in the next one.